Now that we know that there is built-in support to edit the data sets through the analysis file for scalar and vector data, what we are going to do is we are going to proceed with the user interface and try to understand it in a more meaningful way. In this module, we shall understand how to edit the data sets, what are the computations of vectors and the scalars, and then we are going to proceed with some really interesting examples of computations that will give us the engineering kind of output we expect from the simulation study. This is the recap of the data sets and the user interface that we have seen earlier. The menu on the right hand side gives us an allowance to create new elements which are declared as nodes, and it helps us to establish the relationship between data and apply certain statistical functions as computations on scalar and vector data. The symbol that you see here is grouping the data in such a way that you can apply a certain statistical method or a mathematical expression such as multiply, divide, or compute onto a group. Now, when you apply it onto a group, all the data which is part of the group is affected, and the data which is not part of the group stays unaffected. What is computing the vectors? Computing the vectors is actually the application of a certain statistical method or manipulation onto vector data, which is a tuple space, to create another kind of vector data. Because when you apply certain procedure such as concatenation, what you are doing is you are taking the data from one vector, concatenating it with some additional information, and you are sending this or outputting this to another vector. This is how we show the application as a mechanical wheel, which helps us to understand that this is the application of the computation on vector data. Likewise, when we look at scalars, we compute the scalars by again doing some kind of statistical methods on the scalar data. As an example, if we were to determine loss, frame loss, or packet loss, we need to define it by giving it a name, and we need to do some kind of manipulation with the received packets and the sent packets. Specifically, we need to divide the received packets by the sent packets to give us the loss. If the received packets and sent packets are exactly the same, we'll get 1. It means no loss. On the contrary, if the received packets are 0 and the sent packets are, let's say, 100%, it means that the system has lost all the packets and the loss is going to be 100%. With this, dear students, we are finally done with the overall processing and the simulation creation and the visualization of the Omnet Simulation IDE. We are going to continue subsequently with the computation examples later.